7th grade, lesson 57. This is on negative exponents and then also scientific notation for small numbers. Okay? Now, the first thing we're going to do, which is, I think you've learned last year, but let's review it just in case. Okay? So let's do a few of, do you remember what this means?
10 to the 6th power. That means 6 zeros.
6 zeros. Okay, so this would actually end up being 1, 2, 3, 4, 5, 6, right? That would be the answer, correct? Okay, now, we're going to look at, let's say I did 10 to the 3rd. What would it be?
1,000.
Okay, 1 with
3 zeros.
Okay, so you remember that method that we used that one time? Okay, so watch what happens. Okay, this would be 1 million over 1,000. Okay, do you remember what we can do with zeros if they're at the end of the number?
Cross them out.
Cross them out. So let's do that. Okay, so what do I have?
1,000 over 1, which would be 1,000.
Over 1, which
really
is what as an exponent? So this is in standard form.
1 and 3. 10 to the 3rd power.
To the 3rd power. Okay, remember that? 10 to the 6th, 10 to the 3rd. Now, there's actually an easier way to do this. 10 over the 6, watch what happens. Let's say I was doing 10 to the 6th and I was dividing it by 10 to the 3rd, which we just did.
10 to the 3rd.
And we got 1,000 over 1, right? Which is really 10 to the 3rd. But there's an easier way of doing this.
Can you subtract the exponents?
Yes, you can. Okay? We've learned in other lessons
before
that when we're multiplying 10 to the 4 times 10 to the 2nd, we can actually add those. Do you remember us doing that?
Yeah.
So it would end up being 10 to the 4 plus 2 is 6. Right? Okay? Well, just like you would add with multiplication, you're going to
subtract with
division. Okay, so stay with me. So this would be 6 minus 3, which would end up giving us 10 to the 3rd power, because 6 minus 3 is 3. Remember that? Okay, so let's do a few of these. 10 to the 5th power divided by 10 to the 3rd. What would my answer be?
10 to the 2nd.
Okay, so you're understanding it really well, okay? But watch what happens when I make it into a standard number. What would 10 to the 5th power be?
That'd be 10,000. No, yeah. 100,000.
100,000. 1, 2, 3, 4, 5. 5 zeros. Okay? Over 10 to the 3rd power. 1, 2, 3. 1,000. So we're going to cross out like we were. And you'd get 100 over 1. And 100 over 1 is really 100.
10 to the 2nd power.
And it would be 10 to the 2nd power because we have 2 zeros, right? Okay, so are you understanding the fullness of it?
Yeah.
All right, well, let's keep going. What would 10 to the 4th power be over 10 to the 3rd?
That'd be 10.
10
to the 1
power. Okay, stay with me. What would 10 to the 3rd power over 10 to the 3rd power be?
That'd be 1.
Okay.
10 to the 0 power.
10 to the 0 power. Okay, now, stay with me. When we were doing 10 to the 2, what was the final answer?
100.
100. When we're doing 10 to the 1, what would it be?
10.
10. And when we do 10 to the 0,
it'd be 1.
It would be 1. Now, that's very important for you to know. Okay, so I want you to write that down, that anything that has an exponent of 0, the answer will always be 1. Okay, so when you looked at this, 10 to the 0, you wouldn't automatically go, okay, that equals 1. But if you actually work it, 10 to the 3rd power divided by 10 to the 3rd power, you would know that equals 1 because 10 to the 3rd power is really that over that, and 1 over 1 is 1. So it makes sense, yet when you look at it in that way, does it make sense? You get it? Okay, we're going to start working with other numbers than just 10. So you may see 4 to the 0 power. Guess what it's always going to equal?
4. 1?
1. Everything always equals 1. Okay, so write that down. That was a good guess because we were working with 10.
Yeah.
Therefore, yeah. But this is 10's an exception when you're looking at scientific notation. Okay, so we'll talk about this in just a minute in this expression. Okay, now. Okay. Now stay with me because this is when it starts getting hard. All right. Just like a while ago, we were learning that you divide when you're dividing exponents to subtract the exponent. Remember that? Mm-hmm. Okay, so stay with me. If you solve this over this, the answer would be what?
That'd be 100. That'd be 10.
10
to the first power.
To the first power. Okay, now stay with me. Now watch what happens here. If I say 10 to the second power over 10 to the third power, you're actually doing 2, the top one minus the bottom one. So this would be 2 minus 3 on the exponents.
It would be -1.
It would be a -1. So the answer here would be 10 to the -1.
Okay.
Now, stay with me. Are you understanding this thought so far?
Yeah.
Okay, I'm going to erase this for just a second.
Okay.
I'm going to write it over here. 10 to the -1. Okay, so stay with me. Let's do its standard form. 10 to the second power, which will be what as a standard number?
100.
100.
Over 1,000.
Over 1,000, 3 zeros. Okay, stay with me. One over 10. Which really is 10 to the -1. This is very hard for your brain to grasp, but stay with me because we're going to keep doing some more. Okay, let's try this one. This is hard for the brain, okay, so if you're struggling, it's okay, you'll eventually get it as we keep working. Okay, let's do it the normal way. What would the answer be?
10 over 1,000.
Okay, what?
10 over 1,000.
No, tell me 1 minus 3.
Oh, that'd be -2.
-2, so I'm going to put the answer is 10 to the -2. There, okay, so now let's work it out standard way.
10 over 1,000.
10, 1 0, over 3 zeros. Cross out 1 over 100, which equals really 1 over 100, which is what as an exponent?
Oh, 10 to the second power.
10 to the second power, which equals 10 to the second. 10 to the
Why
-2.
wouldn't you on the bottom one, when it says 1/10, why wouldn't that be?
I could put a 1 here
10
because there's 1 0.
Okay.
That's probably what I should do because it makes more sense.
Yeah.
All right? Are you with me?
Mm-hmm.
1 10 to the 2 equals 10 to the -2. This is hard for your brain. Okay, so stay with me. Let's try another one. Because I'm going to show you a trick in just a second. 10 to the second power. 10 to the fifth power.
-3.
-3. 10 to the -3 equals standard way.
100 over
2 zeros over
100,000.
5 zeros, 3, 4, 5. Okay, if we were to work this, we'd go boom, boom.
1 over 1,000.
1 over 1,000, which is really 1 over
fourth power. 10 to the fourth power.
1, 2,
3, third power.
10 to the third power. So I want you to see a correlation between how we write this. Every time you see 10 to the -33rd power, 10 to the -3rd power, anytime you have a negative exponent, I want you to think in your head, I need to flip this 10 as a reciprocal. So when you see a negative exponent,
just take off the
when it's like this, you're going to flip. Instead of it being a 10, you're going to make it 1/10, and whatever the exponent is, you're going to put. Okay? So that's the trick we're learning today. Okay? It makes sense when you do it on paper, but you're going to need to not have to do it all in paper. You're just going to need to know that this is the same thing as this.
Can we do another one and let me try it?
Yep. Okay, ready? So let's do 10 to the third power over 10 to the seventh power.
-4.
-4. So the answer would be 10 to the -4. what am I really going to get if I put it without the negative form?
1 over 10 to the 4th power.
Very good. Now let's check and see if we get it right. This is what we want our answer to be. So this would be 3 zeros. This would be 7 zeros. 1, 2, 3, 5, 6, 7. Cross out, cross out, cross out. I have 1, 2, 3, 4. 1 over 10 to the 4th. Perfect. Okay? While it doesn't make sense in your head, it does. Are you with me?
I get it.
Did you agree with that?
I get it now.
Okay. Now, so, tell me this, Isaac. What would this be?
Oh, that would be 1 over 10 to the 2nd power.
Perfect. What would this be?
1 over 10 to the 4th power.
What would this be?
1 over 10.
No.
1 over 10 to the 0 power.
Okay?
1 over 1.
Just 1. 1 over 1, which is
1.
1. Remember, anything to the 0 is
1.
1. Okay? That's your rule. All right. Now, so let me trick you up just a second. You've been working with 10s to the negative 2. What if I did this? First of all, tell me what this one will be again.
Oh, that'd be 1 over 10 to the 2nd power.
Okay? Now, I'm going to stick a different number in here. Most of the time, scientific notation doesn't use different numbers than 10.
Okay.
They're wanting to teach you something here, so watch this. They're going to give me the number 3 with a negative 2. Following the same pattern, what would this be?
1 over 3 to the 2nd power.
Okay? And let's go on and finish it out. 1 over what is 3 to the 2nd power?
9.
Final answer, 9. Okay?
1 9.
Or 1 9, sorry. Yeah. You understand it?
Mm-hmm.
Okay? Think you got it?
Yep.
All right. Now, they're going to show you this. I don't know if they'll ever do this on a test. Okay, so they're going to give you a letter. For example, A to the 0 power. What does 0 power always equal? 1. 1. Okay, so A could be any number, whether I use a 10, a 3, an 8, 7, 4, whatever.
Yeah,
Okay?
literally 1.
Right. Okay, now they're wanting to use letters on this one. A to the negative n equals 1 over a n. Now, they're just using letters. Let's put numbers in here. 10 to the negative 2 equals 1 over a was 10,
To the 2nd
n
power.
was a 2. Okay, so you understand this, right?
Yeah.
This is the, if you were to have a formula, this would be the formula.
Okay.
You don't have to know it. It's not important to that extent. But they're just trying to show you the pattern, that it always is this way.
Mm-hmm.
Okay? You feel like you understand what I'm saying?
Yeah.
Okay. Last thing. Okay. Now this is where standard notation to me gets easier. Okay? So let's do some of the easier ones. Alright? Let's say I had this number, 6.32 times 10. Now when you put a times in there, they will always have 10 as your standard notation, or your scientific notation. Times 10 to the 7th. What have you learned so far about doing this one?
You can just,
Do you remember?
yeah, the 1, well, you'd have 7 zeros.
Okay, so this 10...
But you
actually,
move the decimal over 7
Yes,
times to the...
because you've learned so far that 10 to the 7 is actually 7 zeros, right?
Mm-hmm. Which would
Which
also
is
mean
10
move the
million.
decimal over.
So when I multiply 6.32 times 10 million, we've learned that you move your decimals however many zeros there are. Remember that?
Which would be 7.
And we know how many zeros there are just by looking at this, so we don't even have to do this part. So I'm going to move this how many times?
7.
So watch this. 6.32, and so I'm going to go 1, 2, 3, 4, 5, 6, 7. Fill it in with zeros. Put your period. This one moved. Okay, so what now is my new number?
63,200,000 200,000.
Very good. 63,200,000.
And the decimal is at the end. It just
Yes. And
you wouldn't even need it.
Okay. So you see what we did
Mm-hmm.
now. So the number got bigger when we're working with positive numbers. But watch this. We're going to put a -7. Okay?
Move it to the left.
We're going to move it to the left. You're exactly right. So, what I want you to see is what we're going to do is go 6.32, and this decimal, instead of going to the right because it was positive, we're going to
7
the
times
left.
to the left.
1, 2, 3, 4, 5, 6, 7. Decimal goes here. Erase that decimal. Fill it in with zeros.
If
This is your number.
0.000000632.
Yep. And you can erase this if you want to at the end.
Yeah.
And then that would be your answer with the point right there.
Mm-hmm.
Feel like you understand it?
Yep.
Okay. Try this one on your own. Check your work. Yes. Okay, so what he did is you're going to take this decimal, and which way are we going to go, Isaac?
To the left 8 times.
8 times. 1, 2, 3, 4, 5, 6, 7, 8. Decimal. So that gives me 7 zeros. And that is my answer. Right there. Feel like you got it?
Mm-hmm.
Alright, now, I'm going to leave this up here as your standard for just a second.
Okay.
Okay? This time they tell me this, Isaac. They're wanting you to write this in scientific notation. Now, before you start doing,
I gotta find out where the decimal number was.
Yeah, well,
What the decimal was.
this is where it is.
Where was it though?
Okay? Whenever you're working with scientific notation and they give you a standard number and you're wanting to put it into scientific notation, this is the one rule that you have to write down, okay? I'm going to read it to you. You always place the decimal point after the first digit that is not a 0. Always place the decimal when you're working with scientific notation after the first digit that is not a 0. Okay? So, according to that rule,
Oh, so that'd be the
where would the decimal go?
right between the 3's.
Okay, so it would be 3.3. Now, stay with me. If I wanted it here, I'm going to draw a little line. Okay, I want it there. How many times did I go?
6.
6, okay? But because it's this kind of number that has been moved to the left, the answer is going to be
10 to the 10 to the
3.3 times 10
to the -6.
to the -6. Let's check our work. Are we right? Let's do this problem that we think that we're right about. So I'm going to take 3.3, and I want to go times 10 to the -6. So I'm going to go 6 times. 1, 2, 3, 4, 5, 6. Fill it in with zeros. Am I right?
Yep.
Yes, I
5
am.
zeros in both. Well, besides the 4 before.
Well, the 0 that's in front of it, but it doesn't matter. And I ran out of room. You feel like you understand it?
Mm-hmm.
Pretty good? It's always good to check your work. I can't tell you how many people miss the problem because they didn't check it. Okay? Let's try another one. Alright? My pen's going out. Let's do this one. Okay, Isaac. This is my standard number, but what would it be as a scientific?
1.05.
It'd be, when we figured out that it's supposed to be 1.05 because it's supposed to be after the first non-zero number, okay, times 10.
To the
now,
negative 4.
if I were to put it here, how many times did I go? 1, 2, 3, 4. Negative 4. Let's check our work. 1.05 times 10 to the negative 4 would be this. Negative 4 makes it go to the left. 1, 2, 3, 4. The decimal. Is my correct answer a decimal, 3 zeros, and 105? Decimal, 3 zeros, and 105. That means I've gotten it right. You feel like you understand?
Yep.
Okay, last problem, and it's a comparison problem. And it says 0. We're comparing that to this number. 1 times 10 to the negative third. Now, we know what 0 is. 0 is 0, okay? I'm going to write 0 on top of that, just so we don't think it's something else, okay? Now, what would 1 times 10 to the negative third look like?
0, 0, 1.
0, 0, 1. Okay, so I have a 1, and where's the decimal always if you can't
Right
see
after it.
Okay, right after it. So if it goes to the left
3 times.
3 times, 1, 2, 3, then my answer is 0, 0, 1 with a decimal in front. So, this answer is actually, if you were to have a whole number, it would be 0 as the whole number. If you
It'd be
so which one has more?
the
a
0.001.
Or the 0.01. So this has just a slight bit
Just
more.
barely.
Barely. Because this is 0 as a whole number. This is 0 as a whole number. But then it also has a 10th, 100,000th of an inch or whatever we're working with. Okay? You got it?
Mm-hmm.
All right. That is lesson 57.